Hi everyone, Senan this side, and in this video we are going to see how to implement the doubly linked list, as well as we'll see how to implement insertion at head, right? Like you can see right here. And in the later videos, we'll actually do the separation of implementation, declaration, and the main function itself. But for the time being, let's create everything in a single file because that's easy, nothing else. So since I am only having a single file, we don't need this remaining part. I'll just increase the font, so that is because of which it would be easier for you to see. So let's get started. So we are actually going to create a doubly linked list, right? And this is one of the most easiest, most interesting data structures because this would act as a base for understanding trees, binary search trees, AVL trees, red-black trees, and understanding this linear structure would actually help you a lot. Okay, so initializing with a class node, and what you could do is DLL node as well, doubly linked list node, but I won't be doing that. Additionally, you can implement this class inside the linked list class itself, but that's a topic for a different video. Okay, so what do we need? We need an integer value that would store the value. Then we need a next pointer. So node star next pointer. And the thing that makes this node a doubly linked list node is this node star previous node. So I have the next node, I have the previous node, and I have a value stored in me. So assuming that I am a class node, and whenever you declare a class in C++, you end this with a semicolon like you do it with a struct. Anyways, okay, so here itself there are a couple of problems. First, we don't have a constructor, so let's define a constructor. So node, and the constructor has the same name as the class, and we are going to have a parameterized constructor. That means I would be passing a parameter or the value of this particular thing, so value. And what I would do is I'll say colon, and I'll assign val to this value, and then I would assign this next to null or null pointer, and the previous to null pointer as well, and then I can open and close braces. Then just save this. Okay, now let me just drag this terminal to the right. Okay, so what are you seeing here? So this way that I'm trying to initialize I'm writing the constructor, this is a C++ way to write the constructor. Otherwise, what you would have done in C, in a struct, obviously, would be you would write the constructor inside this, whatever you want to do or initialize, you would do inside these braces. But this is the C++ way, and I like that. So that is why I'm doing this. Okay, now we still have some issue, and that issue is what? I'll give you a moment to think about this, but if you want, you can pause this. The issue with this is actually that we don't have a public before this, right? Because the constructor that we are going to call should be public, right? And these values should also be public because we need to access them later on. There is a way, like a getter and a setter, you can use that and make these variables as private, but for the implementation and because of the thing that we are actually trying to understand a doubly linked list, we are not going to do that. Okay, so that's it, and let's just initialize a node star node, which is equal to new node, and let's add a value 17 to it. And through this, let's just see if this is actually compiling. G++ main.cpp, and let's say it compiles or not. So dot or a.exe. So this is compiling, this is working. And now let's actually implement the doubly linked list class. So class DLL, right? Doubly linked list. And again, open and close parenthesis, end with a semicolon. You would have a public and a private, right? And you can always access private variables within the class itself. So what would be the private variable here? So the private variable here would be the head itself, which would be a type node star, a pointer to the head. And let's say if we initialize a constructor or we create a constructor, I'll say DLL, and let's say I'll assign head to a null pointer. And yeah, the C++ way of implementing the constructor. Okay, so initially our head would be null. Now that's about this. So let's write it in a way. So let's implement insert at head. So what I would do is I would declare a void type, because I don't have to return anything, because I would have the head pointer, which is the starting point of the doubly linked list, already stored in this class. So what I would write is either insert at head, and the thing I was thinking was to name this as push front, the common name that is used in your STL library. But for the explanation, let's write this as insert at head. Now, what do we insert at head? So the thing that we are going to insert is what? It's a value, an int value. So this is what we are going to insert. Okay, so first of all, if I need to insert at head, I know for sure there would be a head pointer, and I'm 110% sure that I would be able to add this. So what I can do is I can just initialize a node star new node, which would be what? It would be a new node which is having this value, right? Because since I'm inserting at head, I can insert at, and since I can insert at head, I can just create or allocate memory for that, right? So that's about that. And definitely, now that I think about this, I should have written a destructor for my singly linked list class as well. But let's say I'll keep that for a different video. Okay, so now I have this new node. And since we are at this new node, I have to check a couple of things. If my list is empty, so if, what do I say? If head is equal to null, or the other way could be if not head, that means head is null. So what do I have to do? I would say that head is equal to this new head, new node. So my head would be this new node, and then what? Nothing. Then I can just return, because there are no nodes, so I'm not worried about any other links being disconnected or incorrectly connected. I'm clear about that. If head is equal to null, or if not head, I assign this head as a new node and then return. So this ensures, or this tells me that this is the case where list is empty. The other case is where list is not empty, right? These are the only things that you have to consider. If node is null, if node is not null, if node is null, if node is not null. These are the only things that you have to think about, and if you know it for sure, you would be able to do this very easily. Okay, so now since I have to insert this at head, so I need to reassign some links. So this new node next should point to what? Since this is the new head, the next element should be the head of the original linked list. So this would be the head. So whatever linked list I already have, that would be now the second node in this new linked list. Now, since this is a doubly linked list, so this is the case where you just have a single linked list, right? You don't have to consider the previous pointer of this head. Now I have the first link that this new node's next pointing to the original list's head. Now, this being a doubly linked list, I need to have the previous link as well, right? So the head's previous should be this new node. So I can say head's previous is equal to new node. Now, what this does is it reassigns the link. So new node's next is the head, head's previous is new node. So I have this link. Now the only thing I have to, okay, so that comment that you see is from the llama already installed in this. Anyways, so new node's next, previous of head. I have that links. Now the only thing that is remaining is to reassign the head, because the head is actually pointing to the second element of the list. So what I do is I say head is equal to new node. I'm saying this new node is now the new head. And after this, it's always a good practice, even in a void function, to return in the end. Okay, so I am assuming that this is good enough. And what can I do? Let's do this. Let's write a cout, and let's say constructor called, right? So this is just showing you that constructor is being called. Not important, not required for this video, but I just want to see the constructor and the destructors being called. And let's say tilde DLL, this is the destructor. And what I'll say, because destructor never takes an argument, right? So I could say that, what can I say? Cout destructor. So you would see this when we actually do the printing and the function actually terminates. You'll see this, how this is working. So ended. Okay, so this is the constructor and the destructor. So this destructor is not complete. So let me, let's just check this first. If this is running, then we'll complete the destructor, because that is not majorly part of the video, but why not? Okay, so what I can do is I can first create a doubly linked list, and let's say DLL star new DLL is equal to new DLL, or just this. let's just declare a value. Now what I can do is I can write a for loop for int I0, I less than, let's say 10, I plus plus, or let's take this as from 1 to 10. And what I can do is I can say dll dot insert at head and the number I. Now the thing that we are missing is how do we check? So let's me just write a print function for this, void print, and what this does is it takes a temp, or not just a temp, a node star temp, which would be pointing to head, and while temp I'll just see out temp's value, and I'll just add a space in between so that we have a proper separation between the values, and in the end see out endl, and I'll not do the mistake that I did in the singly linked list video, which is temp is equal to temp's next. Okay, so you see this, we are actually printing at the end. Okay, and what I could do is I'll just remove this and I'll say that if temp is equal to null, what I can do is I can just print out see out endl. Fine, that's not important why, but let's just keep it that way. Okay, so after this insertion what I can do is dll dot print, and this would be printing my doubly linked list. So let's just compile this. Okay, so compilation without errors a.exe. Okay, so you're saying constructor called, when you have created this would call the constructor would actually do the initialization of the head pointer, then you inserted from 1 to 10 to the head. So when you inserted 1, you have only 1. When you insert 2 at the end, 1 is shifted to the right, 2, then 3, then 4, then 5, and so on. And the last element that you insert at head is actually 10. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And this is the list. Okay, so now there is a slight issue with this destructor because we have allocated memory. We have not deleted that memory. So what I can do is I can say node star temp is equal to head, right? And I need to, what I'll do is I'll traverse the list, and while traversing I would delete the list. So node star or next node would be what? Temp's next, and let's just delete this. So what can I do? So while temp, or I can say could just keep this like this, and what I'll do is I can say next is equal to temp's next, and then delete temp, and then temp is equal to next. And additionally what I can do is I can take this control X, delete this line, and take this inside itself. Okay, so node star next, and yep. So let me just compile this once again. So what you see here is actually I'll take the temp, I'll store the next element, and what I'll do is I'll delete this temp node, and then I'll update this temp to the next node. Now I cannot do the temp next beforehand, so I had to store this temp next beforehand, because if I delete temp I would lose track of this temp's next. So I store that and then do the deletion. So I have constructed my list from tail to head in a way, and then I delete from head to tail. Okay, so that is about this doubly linked list, and let's just actually separate everything. So in this time I won't be having 3 files like the previous one, but what I'll do is I'll say dll dot or the header file, and in this header file I'll keep all the implementation as well as the declaration so that it's not confusing. So I would be requiring this everything, and yep, paste this, save this, and what I will do is I'll just remove these implementation or the class itself so that I have a clean implementation. Now what I have to do is hash include and dll.h. This is dll.h is my own header file, which is actually this one, the one that we implemented. And let's just run this, or oops, what I can do is run code. So constructor called, it's working fine, even if I have separated the implementation declaration and the main function. So what we have done in this video is, if you allow me to conclude this, the thing I have done is I've created a node class, created a doubly linked list class, and in this doubly linked list class I've implemented basically a couple of functions, 4 functions. One is the constructor, one is the destructor, one is the insert at head, and one is the print. but the topic of the video is inserting at head. So that's about this insertion. In the next video, what I'll do is I'll take this itself. I'll try to insert at tail, then I'll try to insert anywhere in the middle, and that is how we are going to proceed in this series. So anyways, thanks for watching, and I hope I was able to teach something to you. This is simple, and if you're watching this for any different language, or let's say if you know Python or Java, which I'm not showing the code here, I would love if you would type that in the comment section down below. And that's it. I'll see you in the next video. Bye.